Hello. Today we're going to be working with lessons 7.5 to 7.7. You should have had an introduction to this already using your trig ratios, sine, cosine, and tangent. We're going to use those today to be able to solve for side lengths. And you're going to want to make sure you have either a trig chart or a calculator where you can calculate your trig ratio to help you work this out. A calculator is definitely going to be helpful in solving these equations because you're going to be working with decimal values either way. So please make sure you have access to that as you work with your notes and when you go to work with your assignment in this section. Let's go ahead and take a look at the notes themselves so we can go over these. All right, so just as a review, okay, the trig ratios that you are going to be using are sine, cosine, and tangent. When using your sine ratio, you want to set up a fraction comparing the opposite side to the hypotenuse. If you're using your cosine ratio, you want to set up a ratio comparing your adjacent side to the hypotenuse. And when you're using your tangent ratio, you want to compare the opposite side to the adjacent. You have to look at your example first and make sure you know which sides you're comparing, because there's only one trig ratio that will compare those two sides. Okay, second thing I want you to check before we start looking at our examples is you need to look at your calculator and make sure that it's set into degree mode to work with your trig functions. Okay, in the calculator itself, if you're using a graphing calculator, I've got a mode key right here at the top, and you can see my angle menu right here where I can choose between radian and degrees. Okay, we're going to be working with our angle measurements in degrees, so we want to make sure our calculator is in degrees. If you have a scientific calculator, you're going to see DEG kind of at the bottom of your little calculation screen to show that you're in degree measure. You see RAD, that would stand for radians, and you need to convert that to make sure it's working correctly. It's always a good idea to calculate a trig ratio and just compare it with your chart. So like if we put in like the cosine of 59 degrees, okay, look that up on your trig chart and make sure your decimal is matching the value for the cosine of 59, and then you know everything's set up properly or working correctly. Okay, so one thing to kind of check there as you go to work on your assignments. All right, let's see if we can put this all on the screen. Okay, so as I look at number one, what I should recognize is I do have an acute angle that I can use here, 47. You always have to use one of your acute angle measurements when setting up your trig equation. And if I look at this angle here, 47 degrees, I should notice that I do have the leg that is right next to that angle or connected to that angle at X. So this is going to be my adjacent leg. And I do have the value for the hypotenuse because that side is directly across from the right angle. So this is going to be my hypotenuse. So if I look at my trig ratios, there's only one ratio that uses the adjacent leg and the hypotenuse. That would be cosine. So we should write our equation in this form. So I'm going to write the cosine of 47 degrees is then equal to the adjacent side, which is labeled as X, over the hypotenuse, which is 12. This equation here is really a proportion because you have a trig ratio equal to another ratio. Okay, but what we're going to do is we don't know exactly what this fractional value is. Your calculator is going to give it to you as a decimal, or your chart's going to give it to you as a decimal. You need to make sure that you're using at least 4 decimal places when you type this ratio in to find that value. So the cosine of 47 is going to give me this decimal, 0.68, well, and then this is going to round it to 0 here, because 9, but the next number is 9, so this would round up, okay, to 20. So we have 0.6820 if I use 4 decimal places, okay, for that value, and then equal to x over 12. And then keep in mind what this means in this equation. We have x divided by 12. So the opposite of that is to multiply each side of my equation by 12, and I will have isolated x. So x will be, and again, this is going to be an approximate value because I did round this decimal off, and we have 0.6820 times 12. And I want to take my answer and round it to the nearest hundredth now. So I'm getting a value of about 8.18. And then you should always kind of look back at your triangle and make sure that this makes sense. Well, if I take a look at this triangle had a hypotenuse of 12. Well, 12 has to be the largest side. So I want a value that's a little bit smaller than that, and it gives me a side length here of 8.18. So that definitely sounds reasonable in this problem. So that's how this would work out. Okay, so kind of follow those steps as you're setting up number 2. So the first thing we want to look for is an acute angle that we can use. So I can see in this right triangle, I have an acute angle measurement of 33 degrees. Once you've identified the angle that you're going to use, determine the type of sides that you're going to use in the equation. So I should see that I've got a side length here of 14. Again, this is the side or the leg here connected to that angle of 33 degrees. It's right next to it. So this is the adjacent leg. And then I should see that where I have my variable A, this goes directly across the triangle to the opposite side. So this is going to be my opposite leg. So if I were looking at the trig ratios to select the appropriate one, I want to pick the one that compares the adjacent and opposite side. The only one that does adjacent and opposite is going to be tangent. So I should be writing my equation with tangent in this case. So I would write the equation as tangent of 33 degrees equals, now I need the opposite side in my numerator, so the opposite side was A, over the adjacent leg, which was 14. Okay, now my goal is to find out what this ratio is equal to. So I would type in the tangent of 33, and I'm going to get a decimal value here that I want to round 4 decimal places. So I've got 0.6494 if I were to round 4 decimal places, and then that equals A over 14. Well, A over 14, that really is A divided by 14. So to cancel out the 14, I'd want to multiply each side of this equation by 14. So A will have an approximate value of 0.6494 times 14. And again, we want to round this to the nearest hundredth. So I'm going to get a value here of 9.09 for that length to the nearest hundredth. And you can see if I put that in here at 9.09, you can see here that 33 would be the smallest angle in this triangle. So this would be my smallest side. Okay, this angle here, 90 minus 33, would have been 57. So we get a larger leg length here of 14. And then the hypotenuse would be the largest if we needed to solve for that. All right, let's see if we have enough room here. All right, just to look at number 3. Now in number 3, again, identify the acute angle that you're going to be using. So I'm going to use my acute angle of 50 degrees. Then we identify the type of side used on the right triangle. So I should see that B is my opposite leg because I'm moving all the way across the triangle to the opposite side. And then where I have 10, I should see that 10 is directly across from my right angle. So that has to be my hypotenuse. So now I'm going to go back and look at my choices here and find the trig ratio that compares the opposite leg to the hypotenuse. Well, sine would be my opposite over hypotenuse. So this would be the correct trig ratio to use to write your equation. So we would write it as the sine of 50 degrees is equal to the opposite side of B over the hypotenuse of 10. Okay, so now I want to find the value for that trig ratio. So the sine of 50 degrees is going to give me a decimal value of 0.7660. I rounded that 4 decimal places. And then that's equal to B over 10. And again, to be able to isolate this variable, we need to cancel out the 10. So right now it's divided by 10. So we would need to multiply each side of the equation by 10. So 0.7660 times 10 is going to give us a value for B at approximately 7.66. Okay, and again, if you put that in, you can kind of see that would definitely be correct because the hypotenuse has to be the longest side. Okay, 7.6 is a little less than that. So that kind of makes sense with the values that we need to be getting for these. Okay, again, think about your process in solving this out. Okay, you first need to identify an acute angle. Second, determine the type of sides you're going to be using in your equation. Match those sides to one of your trig ratios. Okay, you have to use the correct one. Write out your equation. Okay, and then calculate that trig ratio. Make sure you know what decimal that is. And then the rest of that should be solving algebraically for your variable. Okay, always look once you have your answer to make sure that that makes sense. Okay, work with these trig equations carefully to find your side lengths. All right, good luck with your assignment here. And as you continue, so let's stop our share.